Okay, continuing on. Find asymptotes, find holes. It's about the denominator. So 1, set that denominator equal to 0. So this guy happens to factor. Factors x minus 2, x minus 1. That is factored and equal to 0. So I can split it up and I get 2 and 1. But that doesn't tell me enough to fill in my answers down here. So then step 2, I look at my numerator. So at x equal to my numerator, which happens to be x minus 2, is to be 2 minus 2, which is 0. That tells me because it is 0, so there is a hole. That's not how you spell that, hole. A hole in the graph at x equal to the number we were investigating here. So there's a hole corresponding to 2. Then at x equal 1, my numerator, which happens to be x minus 2, it's going to give me 1 minus 2, which is not 0. I don't care that it's negative 1. All I care about is it's not 0. And so at x equal 1, there's a vertical asymptote. Then being really careful about what they ask me. If they ask me for the vertical asymptotes are vertical lines have the form x equal number. So x equal 1. But if they just ask me for the x coordinate, well then just give them the x coordinate. And now this too will check. Now we're going to have to futz around a little bit to make it check, but it will check by looking at a picture. So again, I'm going to put the original function in there. Let's zoom in so we can see that better. And so x minus 2 divided by then x squared minus 3x plus 2. And let's just look at the standard window to begin with. Okay, so we said that there'd be a vertical asymptote at 1. And it's not a great graph, but it sort of looks like we do maybe have a vertical asymptote. That there seems to be some sort of vertical action going on here. Now the graphs aren't going to be great. And here it certainly looks like the vertical asymptote is being crossed or touched. And that's just the nature of how the machine is working. The machine is not doing this particularly sophisticatedly. Is that a word, sophisticatedly? And so it looks like it's being touched, but it's not. But it seems like a good enough picture that I certainly seems like it probably does have a vertical asymptote at 1. Now let's mess with the picture a little bit more. The numbers that we were interested in here were 1 and 2. So let's not graph from negative 10 to 10. Let's go maybe, how about negative 2? It was 1 and 2. How about negative 2 to 5? That's going to help us investigate x equal 1, x equal 2 a little bit better. And let's just graph that and see what we get. Now that's looking much prettier. And so now it really does look like we have a vertical asymptote at x equal 1. And it certainly looks like we at least do not have a vertical asymptote at 2. So we've checked the answer at 1. Yes, there looks like there's a vertical asymptote at 1. But we haven't checked the answer at 2. And so I'm going to mess with the graph again, really zeroing in right at that point right there, right what's happening at 2. And so I'm going to change both the x and y axis, trying to get at 2. And it looks like on the y-axis, it also might be right around 2 as also. If I go over the y-axis, maybe it's about 2. So I'm going to press window again. And it was x equal 2. So I'm going to go 1.5 to 2.5. So 2 is going to be right in the center of my x-axis. And then on the y's, just so I can see the y-axis, I'm going to go -1 and maybe to 3, because it kind of looked like maybe it's right around y = 2. So I'm really zeroing in on that place right there, and I'll hit graph. And you can sort of see it, not too much. Let's do it again. So I want to get a better picture. And so we're going to get even closer. And I'm going to get rid of the y-axis there. So we're just going to have to remember that 2 is going to be right in the center. And it does look like maybe that's actually what we counted the y-axis from -1. What did we do? We did the y-axis from -1 to 3. And so net 1, that guy right in there. Let's actually do a trace coming closer and closer to that point. So that's just before 2. If you look down at the bottom, we got 1.9. You can't see it really well, but it's 1.9 and a little more than 1. So I'm going to regraph it. If I look at my y-coordinate there and it's a little bit more than 1, I'm going to regraph it. And I'm going to leave the -2 to 2. But on the y's, I think it was a little bit more than 1. So I'm going to go from 0.5 to 1.5, because it looked like that y-coordinate was just a little bit more than 1. So everything should be right in the center here. And now you can sort of see it. You can see it right there, that there's a missing point right there. Let's get even closer. Instead of 1.5 to 2.5, let's go from 1.9 to 2.1. Really zeroing in on that x = 2. And we'll graph that again. And you can just barely see it, right? It was better on the previous picture. You can, oh, if I zoom in a little bit more. I think better. Don't you love this, doing things in real? Oh, you can actually see it. So I was going to go point at the screen, but you can't see the point, and you can't see me point at the screen. Right above my finger there. Right above my finger. If I get out of the way, you can see a missing hole right there. You can see a hole in the graph right there. And so once I played around with the calculator enough, I could actually confirm that there was a single missing point at x = 2. Now, I had to play around with it quite a bit to see it, but you actually can see that there's a missing point. Now, the bigger, the takeaway here, we can make a check, but if I were a student, what would I really do? If I were a student, I would have just hit the zoom 6, and I got that initially ugly picture. I'm like, well, I don't particularly like that ugly picture, so maybe I would have said, okay, that's not ugly, but we know that we're looking at 1 and 2, so maybe, -3 to 5. Graph that picture. And once I saw that picture, I do see an asymptote. Now, here's an interesting thing. Notice the picture I did there. The asymptote isn't drawn, as opposed to some other pictures we did. Let me see if I can make it draw the asymptote. So there I feel pretty good that there is an asymptote at 1, but the calculator didn't draw it. Let me redo this again, and let's just change that to -4 and see what happens. So I just changed the window a little bit, and notice this time it draws it. So when it was -4, it draws it. This is kind of cool. You guys probably out there saying, no, it's not cool. This is just boring. I wish you would shut up. I changed to -3, and it doesn't draw it. So which one's right? Okay, what the calculator is doing when it graphs these things, it's just making a T-chart, and it's calculating all those values, and then it's just connecting the dots. And for some reason, when it made its T-chart here, the last dot here and the first dot over there, it just didn't connect those two dots together. That back over here, when I did it -4, it isn't really graphing the asymptote. It's not that smart. It's just that it had a point clear down here, and it had a point clear up there, and it just connected those dots. And so it just happened to be that one time I got the asymptote drawn and one time I didn't. The calculator isn't saying, oh, this is an asymptote. It's just happening to connect dots, and it actually mistakenly connected two dots. Because asymptotes really aren't part of the graph. They're imaginary guidelines. And so really the more perfect graph is when I did the 3. That is the more perfect graph, because asymptotes are really imaginary guidelines. The graph itself is just the two curves. The other one that showed the asymptote in there, that was just kind of a faulty thing that the calculator is doing. And so you had to keep in mind that it is the asymptote itself really isn't part of the graph, and it will look like that sometimes the calculator is drawing it in, sometimes it's not. It just depends on what particular numbers the calculator happens to use. And so here, this just came out to be, at least in my opinion, an interesting example of what goes on in the calculator. That sometimes it'll appear to draw the asymptote, sometimes it won't. Doesn't mean that anybody's doing anything wrong. It just happens to be the way the calculator works. But back to before I got diverted about how the calculator is working, this picture clearly shows that I have an asymptote at 1 and not at 2. I have to play around with it much more to see the whole at 2, but very easily you can check the things that are asymptotes. Okay, enough of that. Zooming back out. One last problem on vertical asymptotes, and then we will move on. Find the vertical asymptote. Again, it's all about denominators. So I look at that denominator. I set the denominator equal to 0. So x squared equals negative 25. I take the square root of both sides. And one more time we see that imaginary thing creeping up. And like I said, the only time we're going to use imaginary numbers is if the original instructions just said solve. If the original instructions said anything else, domain, x-intercept, vertical asymptote, you don't want an imaginary number. And so there's no real solution. So no vertical asymptotes. And so none, none, none. So that's vertical asymptotes. And we'll end this video, and on the next video we'll start talking about horizontal asymptotes.